Good morning. Today we are going to do lesson 11.3. We're still doing surface area, and today we're going to talk about pyramids and cones. So on the last video, we did prisms and cylinders, and I forgot to mention that some questions will ask you, instead of for total surface area, they'll ask you for lateral area. And I mentioned that when we talked about the formulas on the day that we went over this formula sheet right here, but I forgot to make mention of it when I was doing the notes on this lesson. So if they ever ask you for lateral area, they just want the part before the bases. And this last plus, that will always be the bases. So lateral area will just be this part of the formula, the part before that last plus. So when you're doing the questions, read carefully, because if it says lateral area, you have less to do. So this problem that was really complicated, that we had to wind up finding the area of this pentagon, which took us to chapter 10. And then in order to find that, we had to use tangent, which took us back to chapter 8. So that problem got real complicated. If this was a lateral area question, we would not have even had to find the area of that base. We would have had it from the perimeter of the pentagon times the height of the prism. So it just makes that question a lot easier. You have to read kind of carefully. All right, here's what we're doing today. So here are the two formulas. This is the general formula for all pyramids, and this is the formula for cones. There is a formula for a square pyramid. So if you want to write that down right here, square pyramid. Now again, you don't have to use this formula. The general formula will always work, and that's true for all the different types of problems. So that is up to you. All right, let's do this pyramid. So you can use the square pyramid formula if you want, or you can use the general pyramid formula. So I think I'm going to do this one. 1/2 perimeter times slant height. So when I make a slant height, L, I make it kind of, it's almost like an E but taller. And that just distinguishes it from length. When I write length and width, I write the L all the way down to the line. Okay, so here it is, 1/2 perimeter. Now, it doesn't really say that this is a square pyramid, but if they only give you one side measure, that thing's a square. So the perimeter is 8 times 4, which is 32. Remember, that means perimeter of the base. So 8, 8, 8, and 8. And the slant height, they gave it to you, is 10. And this means area of the base. And since the base is a square, it's either side squared, or you can think of it as length times width, which is 8 times 8, and that is 64. So see, if this question asked you for lateral area, you only need this part. And then total surface area would be that base added to it also. All right, so 1/2 32 is 16, and 16 times 10 is 160, plus 64, and that is 224 inches squared. So the lateral area is 160. The total surface area is 224. All right, example 2. Example 2 is a cone. Surface area. Ooh, before I do that, I want to show you what if you had used this other formula. 2L slant height plus L squared. So it would be 2 times 8. Remember, L here means length, because it's length and width, but since they're all the same, it's length and length. And slant height, and then length squared. And so you get 160, because 2 times 8 is 16 times 10. So you get that same answer. Same parts and everything. Okay. Cone. Pi times radius times slant height plus pi times radius squared. This is that Mrs. plus Mr. squared, or Merle plus Mr. squared. So pi times radius times slant height plus pi times radius squared. Make sure I put everything in the right place. Okay, so 8 times 12 is 80, and 16, which is 96. So 96 pi plus 64 pi. Again, if they ask you for lateral area, it's the area of just that, the cone part of cone. So not the base circle, but the part of the cone that's going around the lateral face, the side. Anyway, so then this would be the answer if they ask you for lateral area, but we're adding these together, and so you get a 10 and what is that, 160 pi. Yeah, 160 pi inches squared. And that is how to find the surface area of a cone. All right, here we go. This is a hexagonal pyramid. And these are the problems that get tough, and it's because of this pesky base right here. So remember, if you're when you're doing these problems, if it says lateral area, it cuts out a whole big chunk of work on a problem like this. So first, I write down the formula. I have to use this one. Surface area is 1/2 perimeter slant height plus area of the base. 1/2. All right, the perimeter. Remember, that means perimeter of base. So 9 times 6, because it's a hexagon and there are 6 sides. So that is 9 times 6, which is 54. They gave us this slant height right here. Slant height is 14. So see, if they ask you for a little lateral area, then it's pretty easy. This is what gets tough. We have to find the area of that base. So I'm going to draw my hexagon so that I can look at it a little better. And so I'm trying to find the area of this hexagon. Sorry, it's a little squatty. All right, and so I have that this side is 9. And the formula for any regular polygon is 1/2 perimeter times apothem. And we already know the perimeter. We found that already for this formula. It is 54. So the work comes in when we have to find that apothem. All right, so back to chapter 10. In chapter 10, we learned that we need to find this angle. And so 360 divided by 6 is 60 degrees. So that angle is 60. This gets small, y'all, so 60. And then when you draw in that apothem, it cuts that triangle in half, and it cuts that 60 in half, and it cuts that 9 in half. So I'm going to draw that over here. This is 30 now, and this is 4.5. Sorry, don't have a lot of room there. And in a 30, 60, 90, see now it's kicking us back to chapter 8. I don't like how crammed that is. I'm going to put it up here. Sorry. This is 30. This is 4.5. Okay, in a 30, 60, 90, so we're back to chapter 8. Across from the 30 is A. This would have to be 60. Across from the 60 is A radical 3. So if this is A, 4.5, this apothem must be 4.5 radical 3. And so now I have my apothem. 4.5 radical 3. If you leave it in radical form, you don't have to do the approximate. This is exact. So then we just do this. 1/2 times 54. And multiply that by 4.5. And you get 121.5. So this is 121.5 radical 3. So I multiplied the 1/2 times 54 and that times 4.5. And then I just didn't punch that in the calculator, so I just kept it at the end. That is 1/2 perimeter times apothem, which means that's the area of this hexagon. So this hexagon is 121.5 radical 3. And I have to add that to my sides here, my lateral area, 121.5 radical 3. And then we're going to work all this out. So 1/2 times 54 times 14, that is 378. That's the lateral area, plus 121.5 radical 3. Okay, you cannot add these together. These are unlike terms because this has a radical 3 and this doesn't. It's kind of like adding 378 plus 121.5x. You can't do that. So you either leave it like that, Or you work this out and add it to 378. So 121.5 radical 3. Make sure I punch that in right. Yep. You get 210.4442, and you add that to 378. And then round it, 588.4. So this is approximately 588.4. So I can't stress enough for you to read directions carefully, because if this had said lateral area, we would be done with this. The answer would be 378, and we would not have had to do any of this. So read real carefully. All right, last one. Surface area is pi times radius times slant height plus pi times radius squared. Mrs. plus Mr. squared. So pi times radius, this 10 feet is the whole way across. So 5. Now we run into a little problem. That 12 right there, it is not the slant height. That is the regular height of the cone. So from that top point to the center of the circle, that's regular height. We're going to need that number for volume. But for surface area, we need the slant height. We need this line. So we'll come back to that in just a minute, and I'll show you how to find it. Plus pi times radius squared. All right, so this is what it's going to look like as soon as I get that plugged in. All right, let's talk slant height. So I'm going to draw that right triangle right there, because what we've got is two sides of that triangle. We've got the 12, because it's pointing to that line, that's the height, and the 10 is cut in half by that line, so that's a 5. If you happen to remember a Pythagorean triple 5, 12, 13, then you'll know that this slant height is 13. But that's kind of, it's a less common one than 3, 4, 5s and 6, 8, 10s, so a lot of people forget that one. So to find that, you could find this with Pythagorean theorem. And you have 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. This is 169 equals c squared. And then when you square root, if you don't happen to remember the square root of 169 is 13, square root 169 gives you 13. Your calculator will do that for you. So c is 13. And that line right there is c, which is this line if we transfer it back to our picture. And so this is 13. Now, it's going to give you a pretty close answer if you accidentally put the regular height instead of the slant height. So it's going to be really, really important that you show your work on questions like this, because if you're off a little bit, I'm going to, I need to see the work so I can see if you actually put 13 in there or 12. So if you're off, I'm going to assume that you put the height instead of the slant height. And so showing the work will be really important. All right, so we're going to multiply 5 times 13. You get 65 pi. That is the lateral area. This is 25 pi. And you can add those together. Since they both have pi's, you can add them together because they're like terms. And that is 90 pi. Or if you want that rounded, or if the question asks for it to be rounded, you get 282.7. Approximately 282.7 feet squared. Yeah, that's how to do that. All right, so that is surface area of pyramids and cones. Y'all have a fantastic day. Bye, guys.